Alrighty, let's bring it all together, our graphing rational functions. In previous videos, we've talked about vertical asymptotes, horizontal asymptotes, holes, x and y intercepts, and increasing, decreasing ranges, aka slopes. Lots of stuff to all bring together here as we graph our rational function. Here are going to be the steps that I suggest. First things first, start by factoring if it's needed. As you can see in our first example here, we can common factor the numerator, but that's about it. We don't have to do anything fancy. We determine if there's any holes and then add them to our graph. Then we find the asymptotes, add them to our graph. We're going to determine how the function approaches the asymptotes and then add little arrows to our graphs as a reminder. Finally, we're going to find our intercepts and plot them and then pull it all together into a graph. Okay, we're going to do 2 examples total to show you what it looks like when you are graphing a rational function. So first things first, our step number 1 was to factor. So that's what I'm going to do. I'm going to common factor out of 3 out of my numerator, leaving me with 3 bracket x plus 2, and then x minus 1 in my denominator. Okay, check, factor if needed. Are there any holes? The answer is no. There are no holes in this rational function. Now we need to check for the vertical asymptote. In our vertical asymptote, we set the numerator or the denominator equal to 0. And so there is a vertical asymptote at x is equal to 1, which I'm going to add onto my graph here. And recall that I'm using a dotted line because it is not actually a part of the graph. It is simply a guiding line. Now I need to find my horizontal asymptote. And I do that by taking the limit of my function. And actually, I'm going to work with the unfactored version here. As x approaches infinity. Recall that we need to divide all of our terms by the highest degree of x. So I'm dividing everything by x. And we can see that our second 2 terms here will shoot off to 0. And our first 2 terms can be simplified into 3 over 1, which is just 3. So I have a horizontal asymptote at y is equal to 3. I'll add that to my graph as well using a dotted line. Okay, now we need to figure out what our function looks like as it's approaching all of these things. First, let's check our vertical asymptote. Okay, and I'm just going to move this over. Oop. Okay, to check what's happening with our vertical asymptote, we look for 2 numbers that are really close, just one on the left and one on the right. In this case, I'm going to check x is equal to 0.9 and see what happens. So f of 0.9 will be equal to 3 times 0.9 plus 2, all divided by 0.9 minus 1. I'm going to do that in one step on my calculator. I get negative 87, which means it's shooting off to negative infinity. And so I'm just going to add that. I'll add it in pink as well on the left-hand side. Now I'm also going to check x is equal to 1.1. That's on the right-hand side of my function. And I'm going to do that again in one fell swoop. And here I get 93. That's positive, and so I'm going off to positive infinity on the left-hand side of my vertical asymptote. Okay, Let's check for my horizontal asymptote now and how it's behaving. Recall that our horizontal asymptote, we check large values so that we can see what's happening as x approaches infinity and as x approaches negative infinity. So the first one I'm going to check is when x is equal to 100. So we'll have 3 times 100 plus 2 divided by 100 minus 1. And that is a 3.09, which is above my vertical asymptote. So I'm going to add a little arrow above here on the right-hand side. And then I'm going to check negative 100 as well. 3 times negative 100 plus 2 divided by negative 100 minus 1. And I get 2.91 I should say. That is slightly below my horizontal asymptote, and so as x goes to negative infinity, I'm underneath my horizontal asymptote. Okay, so we've got our asymptotes added here. We know how our function is going to behave. Now we need to find our intercepts, and we are going to plot them. Recall that in order to find the x-intercept, we set y is equal to 0. Multiply out the denominator, so 0 will be equal to 3 times x plus 2. Divide both sides by 3. 0 divided by 3 is still 0, so I have 0 is x plus 2, or negative 2 is equal to x. So my x-intercept is located at negative 2. And I'm going to add that dot to my graph right here. Now I find my y-intercept, and I do this by setting x is equal to 0. And then solving. 0 plus 2 will be 2. 3 times 2 is 6, divided by negative 1 is negative 6. And so I add the negative 6 intercept to my graph as well down here. And that makes sense, right? Just looking at my end behavior and what's happening that way. Or I should say my behavior as it approaches the vertical asymptote. We've got our asymptotes, we've got our x-intercepts. Now we can graph. So I'm just going to zoom in on the graph here, and we're going to do our best. There's no exact points in the top right corner, and so you're just sort of hoping for the best. Regardless, it doesn't really matter where they hit as long as you're following the information that you had previously found, i.e. how it's approaching the asymptotes. On this left-hand bottom left corner here, I do have 2 points I need to hit. And then that behavior as it approaches each intercept, or each asymptote. Okay, and that's our function. F of x is 3x plus 6 divided by x minus 1 in orange. Okay. Let's do a second example now. Sketch the function f of x is equal to x squared plus 5x plus 4 divided by 2x squared minus 1. First things first, I do need to factor in order to make this easier on me. And sorry, that shouldn't be a 1, that should be a 2. I have simple trinomial factoring in my numerator. I'm looking for two numbers that add to 5 and multiply to 4. In this case, it's going to be 1 and 4. In my denominator, I can factor out a 2, leaving me with x squared minus 1. And I can actually factor that further because now we have a difference of squares. Okay, it's factored. Now I can see that I do have a whole located at x plus 1. Let's make that bigger. There's going to be a whole at x plus 1. I'm just going to further simplify my function. My numerator will be x plus 4. My numerator will be 2. My denominator will be 2, x minus 1. And we have a whole at x plus 1 is equal to 0, or at x is equal to negative 1. So now I need to figure out what is the y value of my whole, and I substitute that negative 1 into my function. So we'll have negative 1 plus 4 divided by 2 times negative 1 minus 1. Negative 1 plus 4 is 3, and this will be 2 times negative 2, which is going to be negative 4. And so my whole is located at negative 1, negative 3 over 4. And I'm going to go ahead and add that to my graph. And I'm going to make sure that I'm drawing it as an open circle. Okay, it might look a little bit exaggerated there, but that's fine. I want it to show that my graph does not actually touch this point. Okay, cool. Now we need to continue with our asymptotes. We got to figure out other stuff here. So let's do our vertical asymptote. We set our denominator equal, or our denominator cannot equal 0. So 2x minus 1 cannot equal to 0. Divide both sides by 2. I get that x minus 1. And so x is equal to 1. And actually, I don't need the does not equal to here because I'm specifically saying that I'm finding the vertical asymptote. So I have a vertical asymptote at x is equal to 1. I will add that as a dotted line onto my graph. For my horizontal asymptote, I'm going to take the limit as x approaches infinity of my function, and I'm going to unfactor my denominator so that it's easier to see the coefficient on my x. Now I divide all terms by x. I see that my 4 over x is going to disappear, my 2 over x is going to disappear. My numerator, x over x, simplifies to 1. My denominator, 2x over x, simplifies to 2. So I have a horizontal asymptote located at 1 over 2. And I'm going to add that to my graph as well. Cool. And now I need to figure out how our function behaves at each. So I'm going to move this down here and start checking. My vertical asymptote, recall that you're looking for a number just to the left and also just to the right. And so I'm going to check what my function at 0.9 is. F of 0.9 will be 0.9 plus 4 divided by 2 times 0.9 minus 1. Whoa, what happened to my bracket there? And so that'll be 4.9 divided by 2 times 0.9 minus 1, which is negative 24.5. This is going down negative. So I'm going to add that guiding arrow on the left-hand side of my vertical asymptote. Now I'm also going to check on the right-hand side of my vertical asymptote. I'm going to check the value f of 1.1. So that'll be 1.1 plus 4 divided by 2 times 1.1 minus 1. And that's positive 25.5. It's a positive number, so on the right-hand side of my vertical asymptote, I'm going up to positive infinity. Okay, now I'm going to check my horizontal asymptote. I need to check very large values, so I'm going to be checking at x is equal to 100. So f of 100 will be 100 plus 4 divided by 2 times 100 minus 1. 104 divided by 2 times 99 is 0.53 approximately. This is slightly above my horizontal asymptote, which is a half. And so as x goes to positive infinity, I'm slightly above my horizontal asymptote. And then I'll check at x is equal to negative 100. So f is negative 100 plus 4 divided by 2 times negative 100 minus 1. That'll be negative 96 divided by 2 times negative 101, which is 0.48 approximately. This is slightly below my horizontal asymptote, and so as we go to negative infinity, I am coming from below. Okay, now we need to check our intercepts. So our x-intercept will be when our entire function is equal to 0. So it'll be 0 is equal to x plus 4 divided by 2 times x minus 1. Multiply the denominator out, I'll get 0 is x plus 4, or negative 4 is equal to x. 0x. So my x-intercept is located at negative 4. Add that on here. And for my y-intercept, I check what my function at 0 is. So it'll be 0 plus 4 divided by 2 times 0 minus 1. 0 plus 4 is 4. 0 minus 1 is negative 1. 2 times negative 1 is negative 2. And 4 divided by negative 2 is negative 2. So my y-intercept here is negative 2. Add that dot, and we're ready to sketch. Top right corner doesn't have any guiding points, just behavior at asymptotes, so that's okay. Recall this is a sketch. Doesn't have to be perfect. On the bottom left corner, I do have 2 intercepts and a hole that I need to hit, and so I'm going to be a little bit more cognizant as I am sketching this out. Note that I hit the hole and then I continue on the other side to pass through my y-intercept and then down to negative infinity at that vertical asymptote. And this is our function. The original function again, x squared plus 5x plus 4 divided by 2x squared minus 2. And that's it. Well done, everybody.